In the present video, we're going to continue talking about algebra using the software Maxima. And we're going to present today fractions, how to handle fractions in Maxima, algebraic fractions, of course. So we start by opening the present document. A fraction is as simple as a numerator, a binomial in the numerator, and a monomial in the denominator. You could have complicated forms, and this one is actually obtained from SMath Studio. What I did, I typed this in SMath Studio, selected it, copied and pasted. The problem is that when you paste like this, you don't get the regular parentheses like you will expect, because you're bringing it from another software, and then so you have to go and replace those things by hand, because if you do it here, it will give you those braces, but it may not. Let me just try it here and do a rat simp of the previous result, and it doesn't do anything because it doesn't recognize those braces as a legitimate parenthesis for mathematical operations. So you have to actually convert all of that into this way, or simply type it, keeping in mind that when you have x minus y or x plus y, you have to use parentheses in both numerator and denominator. In the end, you get this result. If you want to reduce that to a fraction with a single numerator and denominator, use the function ratsimp, that means rational simplification, to give you a result like this. Fraction and reduction of fraction. Let's start with these polynomials right here and factor them. These have as a common factor 2a plus 3. 2a plus 3 is, although is a square in this case. So if you divide p1 by p2, at first there is this Maxima just copied p1 and p2 and put it in there. If you use the rational simplification, it will take out the common factor and simplify this result into this. Let's try another example here. We define the fraction f, apply the simplification, fraction f, rational simplification. You can see what a reduction that was done in this one. Let's try this one. Simplifies into this one. Residual of the quotient and residual of an improper fraction. Let's start with this fraction, right? This one, if I try rat simp, won't give me any improvement. So it's an improper fraction, and it will have a quotient and a residual. So I'm going to separate the numerator and the denominator using functions num and denom, and it separates the numerator and the denominator, and then use the function divide for the numerator and denominator, and it will give me the quotient as x minus 1 and a residual as minus 3x minus 2. Remember, when you have a dividend divided by a divisor, and this is the numerator, it will going to be equal to a quotient plus a residual divided by the denominator. So if we multiply by d, this result is valid too, and let's check it out in this case. We have q is x minus 1, residual is minus 3x minus 2, and then I'm going to calculate this quantity if this quantity should give me the numerator, which indeed does. This is the expansion and this is the numerator. So this verifies the division. Let's try this one. Minus 2 plus 3 over x minus 1 plus x. Rational simplification of that sum, give me this result. There is no longer any common factor, so it cannot be simplified anymore. We can check that with checking in the numerator of the previous result. It will be the denominator. Yeah, okay, well that's not going to work. Let me just take this. This Control C. And delete that parenthesis. And in here I'm going to copy the numerator. put it to the right of the 2 points of the column, and do a divide. Numerator by denominator, and we get x minus 2 and 3. So there's a residual, so there's no way to simplify this anymore. Other example, summing a polynomial with a fraction and getting that result. Addition, subtraction, fraction. Here, try this sum right there. Is rat simplify. Here's another example. Right, simplify. Yet another case. Rat simplify. Okay. I suspect that the denominator of the resulting fraction can be factored out. Is the function factor. We're going to factor the previous result, and indeed it can be factored out. But the numerator cannot, otherwise it will have been done. Let's try this one now. Let's simplify, factor. Okay, so other ways to present your results. Multiplication of fractions, sorry. We have these fractions f1, f2, f3. We're going to multiply f1, f2 times f3. It doesn't do the expansion. Let's try factoring them, and it simplifies a lot. A rational simplification will actually expand the multiplication. Multiplying mixed expression, we have fractions and polynomials. Multiplying them, simplifying, rat simplification. Here's another case. Rational simplification. Yet another case. Rational simplification. Division of fractions. A rational simplification here. Actually, we have two different fractions, f1 and f2. I'm going to divide f1 by f2 and simplify rationally to give me this result. If I factor them out, I do get some factorization in the numerator because of the difference of 2 cubes, but nothing in the denominator other than the value of 2. f1 and f2, quotient f1 over f2, rational simplification, give me that result. I'm going to present 3 fractions right here. And then I'm going to produce this result, which is f1 times 2 divided by f3. So Maxima has accommodated those factors, but it actually has not expanded them. So with the rational simplification, we get this result. Can we factor that out? And then we can take a factor m in the numerator and in the denominator, but not much more than that. Got another example here. Yeah, f1 divided by f2 by f3. Rational simplification, factoring. Kind of things you can do to simplify. Complex fractions. It ended up in Spanish. It should be complex fractions. It's like a sum of polynomial and fraction in the numerator, polynomial and fraction in the denominator. Rat simple is the way to go. We produce that. Let's try this one right here. I think it's the one that I gave you at the very beginning, and it simplifies to this and cannot be factored by a little bit of factorization. Division involving 0 and infinity. If you divide and multiply by 0, you get 0. If you divide by 0, it's undefined. It's actually what we call infinity. In other words, the numbers grow without a limit. Infinity is represented by this inf. Sometimes it's represented also by INF in lowercase, and it gives you the symbol of infinity. Now, this doesn't make any sense. When you multiply infinity by any number, it's infinity again. And finally, 0 divided by 0 is indeterminate. So in this worksheet that you should have access to, we explore fractions. We did a lot of operations with fraction, and we found that the rat simp and the factor, again, are important functions to use with Maxima. And with that way, we are going to end our presentation on algebra fractions.